teaching Gedera today. We've covered addition, subtraction,
and cooking pilau. Man, he was horrible at cooking pilau. Do you remember? Kibe, isn't that Gedera?
It looks like him. Wait, is he wearing a suit? What's he up to?
Hey, Kibena, Kiduchu, can you give me a hand?
Wahoo, Gedera. You're looking flashy today. What's with the suit?
Yeah, really spiffy.
I've decided it's time to turn my life around and become a modern man. I'm done with all this butter trade in the forest. I'm opening a business to make real money so that I can eat pilau every day.
Nice, Gedera.
Whoa, the car's already full.
Don't worry, Gedera. We'll carry the rest of the fruits over for you.
Thank you.
All right, Kibena. We need to move fast if we're gonna get all these fruits to the market.
It's all good. We'll work hard and we can do it. Mambo. What makini? That means be careful. You could have killed me with that pineapple.
We're sorry.
Learn to carry your fruit the proper way, girl. Come on now.
What's going on here? What's on this racket?
This girl needs to learn how to carry her fruit the proper way. Bigger pieces on the bottom, smaller pieces on the top.
Thanks for coming, Mama Ndege. The Chura here is just confusing us. What does she mean? She's using all these words we don't know. Papa, ploppa, what was it again?
Proper. It means to do something correctly, in the right way. Haven't you learned about proper fractions?
She's asking you a question. Where are your manners? Now answer, girls.
But we don't know what a proper fraction is.
Oh my. A proper fraction is a fraction where the numerator or the number on top is smaller than the denominator. That is the number on the bottom.
That's right. It's a fraction where the numerator is less than the denominator. It's only proper to have the bigger piece on the bottom.
Now, Kiduchu, show us how you were carrying your fruits before. No wonder the pineapple fell. It's because you tried to balance something big on top of something little. In fractions, that happens too. But it isn't proper. We call those top-heavy fractions improper fractions. Their numerator is bigger than their denominator. Like 5 halves. It is top-heavy, just like a big pineapple on a little mango.
And that's why we call it improper fraction.
Yes, Nachura is right. Now let's take a look at how Kibena is holding her fruit. She's put the big thing on the bottom and the smaller thing on top.
Now that's proper.
For example, 2/5. That is a proper fraction. The top number or numerator is less than the bottom number or denominator.
See? My fruits are proper and yours are improper. Now make your fruits proper, Kiduchu, and let's get moving or we're making Gedera late.
Now you've got it right, girls. Let's get going now.
Kwaheri. Bye-bye. Carry 2
And you can carry 1.
What, Kibena? No, I should be carrying 2.
I'm going to carry it. And it's over.
What's wrong with you, Kibena? Maybe you should just call Gedere to carry it himself.
Gedere! Hey, Gedere! Look what you've done now, Kiduchu. You've gone and broken the last watermelon.
What is all of this fuss over here? What's going on now, girls?
What's all this mess?
Kibena's hogging the watermelons. She thinks she's stronger and should be carrying 2.
Kiduchu was so jealous she tried to grab the other watermelon from me. And she dropped it. It's broken in half.
Well, since you have broken it, at least you can each have an equal amount. You take half, and you take half. And it works out evenly. Kibena is carrying 1.5, and Kiduchu is carrying 1.5, because 3 divided by 2 is 1.5. There is nothing to fight over now, you silly girls.
And now we are using mixed numbers.
Mixy what?
Mixed numbers.
You get a mixed number when you put a whole number together with a fraction.
Just like you've mixed a whole watermelon and a half watermelon, a whole and a part.
You understand, girls? Now get moving. And I don't want to hear any more arguments between you two. Nachura and I will accompany you.
Finally, we're finished. I'm exhausted.
Whoa, thank you so much, guys. Asanteni sana. Take this sugarcane as a thank you present.
Thank you, Gedere.
And you too can have one too. Take this.
Asante!
Want me to split them for you? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So how should I divide it?
Well, since there are 2 of us, we should each get 5. That means I will get 5 tenths, and Nachura will also get 5 tenths.
And ours has 1, 2, 3, 4, 5, 6, 7, 8 segments.
So if we divide that in half, you should take 4 eighths and I'll take 4 eighths.
Hold on. Why did they get 5 tenths and each of us got 4 eighths? We did all the hard work carrying all those fruits, and they get more than us? That's not fair.
What don't you understand? Kiduchu, use your Ubongo. Look at your piece. It is 1/2. And mine is also 1/2. Which one is bigger?
Hey, they're the same. How'd that happen?
They are equivalent.
What?
Look here. Listen to me. Both of these pieces of sugarcane are the same length. Your stack of sugarcane had 8 segments. So you each took 4 parts. Kibena took 4 parts. And Kiduchu took 4 parts. That's 4 eighths. But if we simplify 4 eighths, what do we get?
Ah, it's 1/2.
That's right. 4 eighths is the same as 1/2. Good job, Kibena.
Look at our piece of sugarcane. I got 5 out of 10 segments, and Nachura also got 5 out of 10. So you see, since the pieces were the same length, but had different numbers of segments, 4 eighths of this piece was the same as the 5 tenths of that one. And they are all 1/2.
So we call them
Equivalent fractions.
2 out of 4, 3 out of 6, 4 out of 8, 5 out of 10. In the end, they are all the same. In the end, they are all 1/2. 2 out of 4, 3 out of 6, 4 out of 8, 5 out of 10. In the end, they are all the same. In the end, they are all 1/2. Give it to us in Kiswahili, Dachura.
2 ya 4, 3 ya 6, 4 ya 8, 5 ya 10. Zote zinasema kuhusu nusu.
We are off now. Bye.
Kwaheri.
I'd like an orange.
Where's your money? Oranges are 200 shillings.
Aw, but I only have 50. Come on, help me out.
This is business. No way. Hey, Kibena, can you stand in for me for a sec? I'll be right back.
Baraka, come here. I've got an idea that can help you out. You want an orange, but you've only got 50 shillings, right? Each orange costs 200 shillings. So with your money, you can get a quarter of an orange. Because 50 is 1/4 of 200.
Yeah, thank you.
Kibena, what did you do? You're ruining my fruit.
I just sold a quarter orange. You've still got 3/4 left.
What?
I sold 1/4 for 50 shillings, and there are 3/4 left. If you sell them all, you get 150 shillings. 50 plus 150 is 200. You still make the same money.
Oh man, I already turned away so many people who didn't have enough money. Orange for 200. Get an orange for 200. Or half an orange for 100. A quarter orange for just 50. We are selling out fast. Get your oranges now. Yippee! Today I'll eat loads of pilau. Haha!
It's time to pay for your market fees. 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 Remember that the most important thing is to put away your savings so that in the future you
Don't you forget, or else you will regret. Don't you forget, or else you will regret. A fraction is proper, the numerator smaller. A fraction is proper, the numerator smaller. Denominator bigger. Don't you forget, or else you will regret. Don't you forget, or else you will regret. A fraction is proper, the numerator smaller. A fraction is proper, the numerator smaller. Denominator bigger. Time to see what have we got, an improper fraction big on top. Time to see what have we got, an improper fraction big on top. The numerator's bigger, denominator smaller. The numerator's bigger, denominator smaller. It's improper. Don't you forget, or else you will regret. Don't you forget, or else you will regret. A fraction is proper, the numerator smaller. A fraction is proper, the numerator smaller. Denominator's bigger. Don't you forget, or else you will regret. Don't you forget, or else you will regret. A fraction is proper, the numerator smaller. A fraction is proper, the numerator smaller. Denominator's bigger.
come listen to me. Fractions are just a part of a whole. Junior knows fractions. Come on, let's go. Look at these mangoes in the lines. Count them up.
1 through 9. 3 of these 9 mangoes of mine is 3 over 9, all 3 ninths. Math is a language, it's not so hard. When we say a fraction, all we mean is a part.
1/2 the same thing as 2 parts out of 4. 1/2 the same thing as 3 parts out of 6. 1/2 the same thing as 4 parts out of 8. All these are fractions, yes, they're just fractions of a whole. 1/3 the same things as 1 part out of 3. 1/3 the same thing as 3 parts out of 9. 1/4 the same thing as 1 part out of 4. 1/4 the same thing as 2 parts out of 8. It's just math. Fractions are fun, ha ha ha. Fractions are cool, ha ha ha. Fractions are great, ha ha ha. Back to improper fractions. The numerator's bigger, denominator smaller. The numerator's bigger, denominator smaller. Big on top.
If you look at half, that is 1 out of 2. It's equivalent to 2 out of 4. And the equivalent in Kiswahili is wafikiana. If you say 1/2, that's like saying a group of 2 things, but only taking one of them. Take one and put it over here. Take one other and put it over there. Take the other and put it over there. So each of them is 1/2 of the group. Now 2/4, that's like having a group of 4 things and dividing it in half. So you have got 2 over here, 2 over there. Now you see it? In the group of 2, we are also dividing it in half. So we can say that 1/2 is equivalent to 2/4 because 1 is half of 2 and 2 is half of 4. Wow! You kids are gonna know your fractions. They're gonna be easy for you from now on.
Don't you forget or else you will regret. Don't you forget or else you will regret. A fraction is proper, the numerator smaller. A fraction is proper, the numerator smaller. Denominator's bigger. Huh? Can you help me out? My car is out of gas and I need a lift to the nearest station. Can you give me a lift?
Yo, what up, Ngedere? I hear these days you're running things back in town. What's got you back out here in the bush?
Don't remind me. Life got me down. I tried my best, but that business didn't work out. Still, I'm working on new ideas every day.
Well, I'll palm then. Let's do this. Karibu! Welcome, listeners, to the best business radio show around. Today, we'll be talking all about math and how you've got to use your math brain to make sure you know how much money you're making and how much you're spending, so that at the end of the day, you can make a profit.
If you want a profit, you have got to plan it. If you want a profit, you have got to plan it. To be a businessman, you've got to have a plan. To be a businessman, you've got to have a plan. If you want a profit, you have got to plan it. If you want a profit, you have got to plan it. To be a businessman, you've got to have a plan. To be a businessman, you've got to have a plan.
This is business. Now listen to me. No success comes for free. Sit down and have a think before you start to sell to ensure you get profit. Plan your business well. How much will you spend to buy goods and space? You must plan it out and have a proper business case. Oh. So when you start to sell, you can set the right price so you don't lose money, because that wouldn't be nice. Just listen to me. Hey, I'm giving you advice. Your business will turn out nice. Remember the math that you learn so you can calculate how much you earn. Just use your brain and have a plan. I insist, you should have a plan. So at the end of the day, you'll be a stellar businessman.
If you want a profit, you have got to plan it. If you want a profit, you have got to plan it. To be a businessman, you've got to have a plan. To be a businessman, you've got to have a plan. If you want a profit, you have got to plan it. If you want a profit, you have got to plan it. To be a businessman, you've got to have a plan. To be a businessman, you've got to have a plan.
What's this radio station? It's got some great advice.
It's called Radio Mikuge.
I tell you, if I'd known of this earlier, I'd be a millionaire by now.
Whoa, Derek, this song sounds like your jam.
Yeah, totally.
Doesn't your car have a radio?
Yeah, of course it does. With great sound. Boy, do its speakers rock.
Just tune into Radio Mikuge. Get loads of business advice.
What's the number of the station?
You can get it at 102.5 FM. It's free business education you get here. Listen, take heart, and I know your business will succeed.
Yippee! It's running! 102.5 FM, eh? But why can't I find 102.5? Hey, buddies. You coming to pay me a visit or just checking out my cool car?
Ah, Ngedere, you're a funny guy. We're just passing by on our way to beat the boys at football again. And if we stay here too long talking to you, we're gonna be late. Kibena, come on, let's get moving. We don't want to back out on this day.
Kibena, hold up. Can you help me with something
What
first?
is it now, Gedere? Is your car not working? You need some strong girls to push it.
No, but I want you to help me find this radio station that I've been looking for, but I can't seem to find.
But we'll be late.
Don't worry. If you help me out, I'll give you a ride in my car and we'll get there even faster.
So why can't you find this radio station?
Well, there's this show called Radio Mikuge, and it teaches some pretty cool stuff about doing business and saving your money. I had it with a friend and he told me I can get it at 102.5 FM. So now I'm trying to find it on my radio, but I can't seem to find 102.5 anywhere. Look, it's just not there. There is no 102.5 FM.
Okay. I'll see what's the problem. Gedere doesn't know decimals. So that's why he doesn't see 100 and a 2.5, even though it's right there on his radio.
Aha! What are you on about, Kibena? I don't want to listen to this decimals radio, whatever it is. I want Radio Mikuge on 102.5 FM. Can't you explain it to me?
Listen first, Gedere. We're trying to help you learn something here so that you don't ask us again.
Go on and tell him, Kibena, so we can go play football.
You remember about fractions, right?
Oh yeah, I remember.
So now think of that. And today I'm going to tell you about another way of representing parts of things. It's like a fraction but a little different. The numbers are shown like this. The first number, a decimal point, and then different numbers at the end. When we use this dot called a decimal point in a number, everything before the decimal point is a whole, and everything after is less than a whole number. Did you understand?
So you sing it there? You have to listen to me carefully. That station number 102.5 that you're looking for can also be written as 102.5. It's a different way of writing the same thing, and the value is the same. I hope now you understand.
Do you get it, Ngedere?
Of course he does. I just explained it. Now, let's get moving.
Not yet, Kiduchu. I don't really understand.
Kiduchu, we need to explain to him better. That way he won't bother us again in the future and will give us a lift today.
Okay.
Ngedere, so you know that decimal numbers are similar to fractions, but they're represented in different ways. 1 out of 10, 2 out of 10, 3 out of 10. Continue to look by yourself. You see? Using decimal notation, we can represent them like this. The first digit after the decimal point is the tens place. It's just like a fraction with a denominator of 10. So 0.3 equals 3 tenths. You see?
Now, Ngedere, look at this other number 0.5. What's that as a fraction?
5 tenths? Is that right?
You've got it. But there's another, simpler fraction that's equal to 5 tenths.
Aha! It's the same as 1/2.
That's right, Ngedere.
And what if I wanted to get 3/5 as a decimal? What would I do then?
That's simple, Ngedere. You just take the numerator and divide it by the denominator, like this.
3 is the numerator and 5 is the denominator. And now you can divide 3 by 5. 3 divided by 5. Well, you can't do that. So we put 0 in its place, then we multiply 5 times 0, and we get 0, and write it here. Now we do 3 minus 0, and we get 3. Then we need to write 0 here. And of course put it in our decimal point at the right place. Now here we have 30 divided by 5, which is equal to 6. We put 6 here. And 6 times 5 is 30. And write that down here below. 30 minus 30 is 0. And so 3/5 is equal to 0.6 in decimals. Did you understand?
Ah, nice, Kibena. If you didn't get that, there's no hope. Let's go play football.
I got it. I get it now. And I said I'd give you a ride, so hop on in and let's go footballing.
Check them out. How cool.
That's gonna be easy.
Decimals, they are not whole. Decimals, they are not whole. Let's sing about those decimals.
Ndege, I love your song about decimals. It's so catchy.
Did you know I can sing Taarab?
Huh? What's Taarab, Mama Ndege?
It's a special type of music from the coast of East Africa, like what we were singing just now.
Oh, like decimals, they are not whole. Decimals. I can sing Taarab too.
That is good singing, Tiny Tembo. Or should I say TT? That can be our nickname for you. TT. What do you think?
What? I like that. It has a nice ring to it.
Okay, Tiny Tembo. Lend me your ear.
What? You want to take my ear? That's gross.
It's just a saying.
Tiny Tembo.
And I'm going to tell you more about decimals. First, let's review how we write decimals. Do you remember?
Yup. Decimals are written as a number, then a dot, then another number.
Nice, like this. Numbers on the left side of the decimal point are like the normal numbers that we know. But the numbers to the right side represent smaller amounts that are less than 1. The 7 is to the right of the decimal point, and anything right of the decimal is less than 1. It's easy. Let's read this number now.
2.7.
So this is how we show 2.7 on the number line. The 7 is to the right of the decimal point, so if we divide this space up into 10 parts, we can see the tenths. In order to get there, you have to start from 2 and then take small steps along the number line. You see what I mean? Now, let's count them up. 2.1, 2.2, 2.3, 2.4, 2.5, 2.6, 2.7.
Aha! So the digits after the decimal place represent those parts. 1, 2, 3, 4, 5. Those are whole numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. So those are just like fractions, right, Mama Ndege?
Right.
If you take 7 parts out of 10, then that's the same as 7 tenths.
Decimals and fractions both represent parts of a whole. Take a look at 0.3 on the number line. You can count up to it. 0.1, 0.2, 0.3. That's because it's 1, 2, 3 out of 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Did you see that? With decimals, we can now see that the number after the decimal point is a part out of 10.
I gotcha. And now let me convert 0.9 to a fraction.
Okay, show me.
A number with a denominator of 10. A number with a denominator of 10. A number with a denominator of 10. So here I look at the number right after the decimal point, which means a number out of 10. And I can write it as 9 tenths.
What about 0.1?
That would just be 1 tenth. Woohoo! I'm on a roll!
And now you kids watching the show, Go have some fun with decimals.
Koba, watch it. Don't you remember that time the ball went over to Mzee Kigo's and I had to do math problems for half an hour to get it back? If that ball goes over the wall today, I'm not getting it. I'm warning you.
Kiduchu, don't worry. I'm like Messi. The ball goes where I want it to. Kiduchu!
Don't you blame me. You kicked that ball.
But you touched it. Now you gotta go over to Mzee Kigo to go get it back.
I already told you. I'm not going over there again.
Well, I'm not going there. Baraka, you go.
Come on, we'll all go. Hello, Mzee Kigo.
Hello there, kids. What can I help you with today, huh?
Sorry, Mzee Kigo, but our football went over your wall. Have you seen it?
I was inside and I didn't see a thing. Why don't you come in and look for it?
I found it. It's here in the well.
Mzee Kigo, can we please have a rope so we can fish our football out of the well?
Sure. Let me get you one. The rats got to my rope and it's completely destroyed, look. All that's left is this little piece here, and that's definitely not long enough because that well, I believe, is 5.8 meters deep. You'll need to find something else. Now, I've got to get to the fields, but I'll leave you kids with this measuring stick. You can use it and your Ubongo, that's your brain, and you'll find a way to get your football back. You understand?
So, what do we do now?
Mzee Kigo told us that the well is 5.8 meters deep. Let's measure this rope to see how many more meters of rope we need to reach the bottom of the well.
That's right. 0.8 meters.
Man, we haven't even got a single meter of rope?
So if the depth of the well is 5.8 meters deep, and this rope is 0.8 meters long, then we need another 5 meters of rope, right?
How do you know that?
We already know the depth of the well is 5.8 meters. So we take the depth of the well and then we subtract the length of the rope. The answer will tell us how many more meters of rope we need to add. When we subtract decimals, we have to make sure we line up the decimal point so they're one on top of the other. And then we just subtract as we normally would. 8 minus 8 is
0.
Now I bring this decimal down to the bottom in the same place. Then what's 5 minus 0?
So that's why we need another 5 meters. I got you now. We need to add more. So I guess it's time to go look for some rope.
Okay.
Fruits. I am selling fruit. I am selling fruit. Fruit. Come and get your fruit.
I don't need no fruit, but I sure do hope that you could spare some rope.
Sorry, sirs. Would you be willing to lend me some rope?
Practice mathematics like mental acrobatics. Every day, in every way.
Who's that?
This is all the rope I could find.
Man, those fishermen wouldn't loan me even a tiny bit of string. But don't worry, I've got an idea.
Nice one. Now, let's measure to see what we've got.
0.9.
And another 0.9.
9 plus 9 is 18. So I'll write 8 down here, then carry the 1 over.
Don't forget the decimal point.
0 plus 0 is 0. And if we add that 1 that we carried over,
then we get 1.
1.8 meters? That's not nearly enough.
Let's add mine now.
Hold on, we need to measure it first.
1.3 meters. If we add that to 1.8 that we already have from the rope and your shoelaces, what length will we have in total?
This is 11, but I carry 1 over. We get 3.1.
We are not even close.
Don't you worry. Kiduchu's here to save the day. This belt is 0.7 meters long. And this TV cable is 1.2 meters long.
Nice, Kiduchu. So we take out 3.1 meters, then add 0.7 and 1.2.
1 plus 7 plus 2 is 10. So I write 0 and carry the 1 over.
1 plus 3 plus 0 plus the 1 that we carried over is 5.
Wow! We've got exactly 5 meters. Nice one! So if we add our 5 meters to the 0.8 meters of Nzekigo's old rope, then we get 5.8. And that's the same as the depth of the well. Woohoo!
Our girl with teary eyes sat by the well and cried. What was she crying for? She was crying for her ball. But where could the ball be? It was in the well so deep. Use your brain until you can get it back. Use your brain until you can get it back.
That's it! Let's get our ball.
Why doesn't it reach?
I don't get it. We've managed to get 5 meters of rope. Pass us a bucket. Why isn't it enough?
What's up, guys?
I didn't manage to find a rope, but I brought a friend.
Welcome, Mr. Twiga.
Oh, don't call me Mr. Twiga. Call me Uncle T.
Okay then, Uncle T. Maybe you can help us out. We're trying to get our football out of the well. The well is 5.8 meters deep, and we've added up the length of all these different strings, and it is also 5.8 meters. But we tied them all together, and somehow it's not enough. I don't know what we did wrong.
Did you measure them before you tied them together? Take a look at all those knots. They're using up some of the length. Don't you see it? It's because you've used some of the string within the knot.
Ah!
Oh.
So that's why it's not enough. Uncle T, you're a clever one.
Well, then let's find something long to add. I don't know where we are going to find something really long around here. Use your brains, kids.
Something long. Something really, really long. Like your neck, Uncle T?
Baraka, you've figured it out.
Wow, your neck is really long, Uncle T.
Yup, it will definitely be enough. Thanks, guys.
All right, let's go play some football.
I'll be the referee. Now where's my whistle? And if anybody messes up, I'm going to give him a red card. Oh ho.
Math can be easy.
Decimals, they are not whole. Decimals, they are not whole. Let's sing about those decimals. Let's sing about those decimals.
Decimal numbers are just a number, then a point, then a number.
Fractions and decimals are quite similar, we're told. Fractions and decimals are quite similar, we're told. Let's sing about those decimals. Let's sing about those decimals. Here before a point is a number that is whole. Here before a point is a number that is whole. Let's sing about those decimals. Let's sing about those decimals. Decimals, they are not whole. Decimals, they are not whole. Let's sing about those decimals. Let's sing about those decimals.
Decimal numbers are just a number, then a point, then a number. The first digit after the point is 10th place. It's like a fraction with a denominator of 10. The second digit after the point is the hundredths place, just like a fraction with a denominator of
Fractions and
100.
decimals are quite similar, we're told. Fractions and decimals are quite similar, we're told. Let's sing about those decimals. Let's sing about those decimals. Here before a point is a number that is whole. Here before a point is a number that is whole. Let's sing about those decimals. Let's sing about those decimals. Decimals, they are not whole. Decimals, they are not whole. Let's sing about those decimals. Let's sing about those decimals. Decimals, they are not whole. Decimals, they are not whole. Let's sing about those decimals. Let's sing about those decimals.
To show you a little bit more about adding and subtracting decimals, representing whole numbers.
Okay, Mama Ndege. Please explain it to us, Mama Ndege.
So when you are adding and subtracting decimals, we need to make sure that they line up with each other. And you know that the digits after the decimal point
Represent things that are less than 1. Right?
So we also need to make sure that these line up with each other. For example, 2.6 plus 5.3.
That's 2 6/10 plus 5 3/10.
You see how all the places are lined up
on top of each other like this? Just make sure that you've got your decimals stacked on top of each other, and the rest will fall into place.
Why are you laughing, Mama Ndege?
Why shouldn't I be laughing? Math is so fun. I just love it. I love mathematics so much. And I know you love it too. Now you can just add like you would with any other numbers. We are just about finished now, Tiny Tembo. Now you are going to add just like normal.
What is 6 plus 3?
9. In Kiswahili, 9 is tisa.
And what is 2 plus 5?
7. Ndio, in Kiswahili, 7 is saba.
So what is our answer?
7.9. In Kiswahili, we'd say 7.9.
Yes. Good job. You got the right answer. Now you see why I was laughing? It was so simple.
Yep, it really was simple, Mama Ndege.
You see?
And if you ask me a different question, I can calculate it by myself now.
Okay, then let's try it. Here is your problem. 8.5 minus 7.1.
Let me read it in Kiswahili. 8.5 toa 7.1. You think I'd miss an easy problem like this one?
What are you laughing at?
Now I'm happy. This is so simple. We start with 5 minus 1. What's that? Dachura in Kiswahili, 4 is nne. Okay, so I'll write 4 here. Then I add the decimal as usual. 8 minus 7?
1.
Moja. And that's it. We're finished. And the answer to your question, 8.5 minus 7.1, is 1.4. 8.5 toa 7.1 ni 1.4.
Tiny Tembo! Tiny Tembo, you are a mathematical genius.
What's a genius?
You are a genius, and yet you don't know what the word genius means? A genius is someone who is very smart.
Ah, yup, that's me.
Now you got me. Okay, it's time to say goodbye. You've been with me, Mama Ndege, aka the clever bird. Come on now. It's time for you guys to say goodbye.
And me, Tiny Tembo, aka Double T. And with me, Dachura, aka Number Jumper.
Goodbye.
Never miss out on new Ubongo Kids videos ever again. Subscribe today and become the first to know every time new fun educational content is available. Simply type Ubongo Kids English on the search bar. Click on the Ubongo Kids English channel page. Click subscribe on the right-hand corner of your screen. What are you waiting for? You are 3 easy steps away from joining the Ubongo Kids family.